mathematics class by Dr. R.K. Goswami, Infinity Math classes, and then the email
Yes,
date in class.
Yes, that means everything is visible to you. So I requested for the topic to be discussed for the demo class. I'm going to start with this length of curves with you. Okay, the sequence may be different. Now, and let me just give you an idea on what we are going to do and how we are going to discuss this question. So just have a look at the example. And this is a question for you. The length of a sine wave. What is the length of the sine curve? So I hope you know about the sine curve. If not, let me just share a screen with you.
Could you? Right.
Yes. Could I increase the font size?
I can see that.
Okay. So now the question is, and this is a question, and these type of questions will be there for you. There is a sine curve from 0 to 2 pi. If you consider 0 is here, let me just change the color. This is representing 0. This point representing pi. This point representing 2 pi. This is the graph of sine curve. Maximum value is 1. Minimum value is going to be -1. This you already know about the sine curve. The question is, how can I measure the length? So I have to just measure the length along this curve. Am I right? Do I have
Right.
any tools till now? The answer is no. There is no tool till now. So there are two ways. Either we should go directly with the formulas or we should learn the tools. In AP calculus, if the objective is to just get the marks, so it is better for us to go objectively, like using the formula directly. So I'm sharing with you the formula. How should we deal with it? Whenever there is a function like y equals to fx given to us, there is a specific range of x given to us. We need to find out the length of the curve y within this range. In order to get that, you need to get derivative. The length is going to be integration of a to b is square root of 1 plus dy over dx whole square multiplied by not multiply integration with respect to x. This is a formula. If you ask, I can explain you how we can obtain this formula. For the moment, it is not required. Okay, for the moment, it is not required. In your classes, only the formula is going to be important and how you are going to apply that formula. So for this question, we have y equals sine x. The derivative of sine x dy over dx is going to be cos x. So if I ask you what is 1 plus dy over dx whole square, you will tell me it is going to be how much?
It's going to be 1 plus cosine x squared, or cosine squared x.
Perfectly okay. Okay. So this length is going to be, the limits are from 0 to 2 pi
2 pi.
square root of cos square x dx. Now the question is, can we integrate this term? The answer is that all the integrations all are not possible using the analytical method. For some of them, we need to use the numerical approach. Can you please use your calculator and calculate numerically what is going to be this value? Is it possible to you?
Yes, I have a calculator.
Please. You must be having scientific calculator. What is the name? TI?
Um, I have a graphing calculator.
Graphic calculator.
It's
Okay. Use it.
it gave me 7.640. Those are the
Perfectly okay.
yeah.
Perfectly okay. Approximately, and this is the answer, 7.640. 64 units. Whatever the units, this is going to be the answer. Because we have used numerical approach, I wish not to use equal to sign, so this sign will be better sign. Approximately, it is going to be 7.64. Is there any difficulty?
No, not with this.
Perfectly okay. So one thing you may have observed here, in order to find the length of the curve, I'm using derivative and then after integration. Now, look at the statement. This is going to be something important. We will be having questions based on the same. It says that the requirement of finding the length of a curve by this method is that the function have a continuous first order derivative. Whatever the derivative, that must be continuous. If the derivative is not continuous over the range, in that case, we may find difficulties. And how? I will tell you the same using some example. So what is the requirement once again? The derivative we have obtained must be continuous, must be having the property continuous first order derivative, whatever the function you are having. The function whose first order derivative is continuous is going to be called smooth function. Clear? So let me tell you once more. Just suppose you have a curve y equal to fx. This is a function given to you. You will call it a smooth function. You will call it a smooth function. When the derivative dy over dx exists, and not only exists, and it should be continuous also. So whenever these two things are there for y, the function is called a smooth function, and in that case, length of the curve can be obtained using the formula. Okay, and
Okay.
one more thing I wish to tell you, this is the formula we have obtained. We have used actually. This is the formula we have used. Now there is a situation. Sometime like I have started this session writing the function like y equals to fx. It is going to be a function for you. Am I right?
Right.
Sometime I may get an expression like x equals to gy. So sometimes this may be a function. This may not be a function depending upon the situation. So it is better for me to call it a curve. So whenever I'm writing an expression like x equals to gy, I'm using the wording curve there. Whenever you are writing y equals fx, by default it is going to be a function over the domain. Domain can be discussed later on. Clear term? So in this case, how should I obtain the length? So whenever you have a curve, in this curve, the range of y should be given to you, like it may be from C to D. In this case, if you ask me what will be the length, I will be using the similar kind of formula. This time integration from C to D is square root of, I'm going to differentiate x with respect to y, dy over d square dy. So this second formula will be useful whenever I'm having an expression like x equals gy. Later on, you will see that we actually have situations where we need to use this formula. Any doubt up to this point?
No questions here.
Perfectly okay. So it is just a summary for the purpose of summarizing whatever we have discussed till now. I'm just pasting this. Self-explanatory, we have explained this without any issue. Now there is a simple question. Sometime the integration is easy for you without the calculator you can do. Like this question, it is a simple task for you. I hope so. Y is given to you in terms of x only. So is it a function? The answer is yes, it is a function there. I need the arc length. So dy over dx will be, please try to help me. It is 4 square root of 2 by 3. This is a constant term, keep it as it is. The derivative x power 3 by 2 is going to be 3 by 2 into x power half. Right? And the
Right.
derivative of -1 is going to be 0, so no need to write this expression. Can we further simplify? This 3 will cancel out this 3. So I should be able to write like 2 square root of 2 x power half. Now, based on that, what is going to be the length of the curve? And remember, they are asking exact length. That means no approximation. You will not be using the calculator this time. So what are the range? 0 to 1 square root of 1 plus dy over dx whole square, and integrating with respect to x. So just substitute the values. Dy over dx was 2 square root of 2, 1 by 2. What if I put a square on both sides? This will be the expression. It is going to be 2 root 2 square is going to be 8. This is going to be x. Any doubt? Do you agree? What is going
Yes.
to be the square of this expression? So just substitute the value. I think it should be going to be 8x and dx. Can you please help me? What will be the integration of 1 plus 8x?
Okay.
And have I forgot something?
No.
Not till now. Okay, no issues. Just try to help me. What is going to be the integration of this expression?
So it would be so it'd be 1/2 1
It will be
plus 8x to the negative 1/2, and then
-1.
times 8 or plus 8.
Oh, sorry. If you are giving this answer, that means you have differentiated something like that. It is not the integration actually. Okay, there is an error in integration part, whatever you have done.
Then you do the from 0 to 1 at
Oh,
the end.
we can substitute the limit later on. No issues. Right now, I'm just interested in finding the integration. Okay, so you can use substitution method. So just suppose allow me to put 1 plus 8x to be u. That means differentiating 8 dx is going to be du. So this expression is going to be square root of u into dx divided by 8. Agree?
Right.
So this is going to be 1 upon 8. Keep it before the sign of integration. The integration of square root of u du. Further, keeping 1 by 8 as it is, square root of u integration is going to be u exponent 3 by 2 divided by 3 by 2. Right?
Right.
And you should add the constant of integration. Just simplify. This is going to be 2 by 3 u power 3 by 2. And you can now substitute back the value of u. You will get 1 by 8 into 2 by 3 u power. How much should I write? Not u. I should substitute the value of u. 1 plus 8x exponent 3 by 2. This is going to be the integration. Any doubt?
No.
So this was the question for you. Now please help me. So I have got constant terms 1 by 8, 2 by 3, 1 plus 8x exponent 3 by 2. Integrate from 0 to 1. Substitute the upper limit, substitute the lower limit. Tell me what should be the final answer. The answer should be exact. Can you please give it a try?
Okay.
Please.
Would that be 13 over 6?
That is 13 over 6. Perfectly okay. You have got the right answer. Okay. And have you done this working or you have used some kind of calculator? Just asking.
No, I did the work. I wrote it out.
Okay, that is very good. So whenever they're asking exact answer, I need from you the solution. Okay.
So the
Okay.
two separate ones, like it was 9/4 versus minus like 1/12, right?
Okay.
Or
It is
1
going
and
to be
0.
just a second. Just a second. Actually, I have not solved this problem. I can see the answer only. It is 13 by 6. If you ask me, I can just do one or two steps for the solution. You
Okay.
want me to do this?
Yes.
Okay. So in this case, let me just copy the expressions. Just give me a second. Yes. Yes. So let me just substitute the values. I should plug 1 first. 2, 8, they can be cancelled out. 2, 4 is 8, so it is going to be 1 by 12 there. Okay, 1 plus 8 is going to be 9, exponent 3 by 2. Minus, this is going to be how much? 1 by 12. If you put 0 there, it is going to be 1 plus 0 power 3 by 2. So this expression going to be, denominator you will be having 12 there. 9 is going to be 3 square. So if you have 3 by 2, so this is going to be 3, 2 into 3 by 2. So will cancel out. This is going to 3 power 3 is 27. So you have 27 and then after you have only 1, which is going to be 26 by 12. And that is why it is going to be 13 by 6. Any doubt here?
No.
So I hope no issues are there up to this point. Okay. Next question. Let me just take you to the next question. And please try to observe the question and what kind of strategies we are going to use for this particular question. They have highlighted a portion, a vertical tangent. Look at the expression first. We need to find the arc length like before. I'm just asking you what is dy over dx? Should it be going to be 1 by 3 x power how much?
X to the -3.
Perfectly okay. Negative 2 by 3.
Negative, yeah, 2 by 3.
And I'm just putting this negative in the denominator so the exponent is positive. The range of x, if you look, it is from -2 to 2. If you wish, you can include the values. Now, this is an expression given to you. Tell me if dy over dx is defined over the interval or if it is not defined at some points. What is the possibility and what can you just say about this derivative?
Wait, wouldn't the value be between
Oh,
-8 to 8?
negative 88. Perfectly okay. Sorry, I missed that. It is negative 88. Now the question is same again. The value of x is from -8 to 8. Do you think derivative is defined all over the interval?
Um, I don't think it'll be defined when
Perfectly okay. When?
x equals 0.
Perfectly okay. So that is why they have mentioned you. This is going to be vertical tangent. And vertical tangent stands for dy over dx tends to infinity at 0. So that means to say that derivative is not defined. I will not be able to use the formula which I have learned from a to b is square root of 1 plus dy over dx whole square. Okay, and why? Because this derivative is not defined at a point. Any doubt?
No.
But this is the graph of the curve you can see. And the length of this graph can be seen as per the graph. It should be finite there. It is not infinite. What should I do? So I need to change the way. So there were two formulas. I told you one was for y equals fx. One formula was y equals fx. Other formula was when x equals to gy. So let me just try to write down the expression like this, x equals gy, and use the second formula. The only difference here will be I need to plug the limits of y there from c to d. And dy over dx is going to be dx over dy. Otherwise, it is going to be simple integration. So because of the derivative not defined at a point, I'm shifting to rewrite the expression. So I was having y equals x power 1 by 3. So let me just take exponent 3 both sides. So what I will have y cube equals to x. I wish to rewrite the expression like x equals y power 3. Any doubt?
No.
Earlier, as you corrected me, the range of x was from -8 to 8. This time, the range of y is required. And by looking at this given expression, range of y is from -2 to 2. Okay. Help me with
Okay.
dx over dy. Is it going to be 3y square?
Yes.
No confusion?
No. It would
Perfectly.
be 3y squared.
So what should be L? L should have the range of y, that is -2 to 2, the square root of 1 plus dx over dy whole square, integrating with respect to y. Just simplify the expression, -2 to 2, square root of, it is going to be 1 plus dx over dy square is going to be 9y square. Sorry, 9y power 4 should be the value here. Any doubt?
No.
And now again 9y power 4. I do not have analytical method to solve it for the moment. I'm asking you to make use of your calculator and tell me what should be the answer.
Okay. Would that be approximately 13, 12.99?
What I can see, it is going to be 17.
Oh, 13.
No, it should be 17.26, something like that.
Okay.
Can you please check once more?
Oh, I put it to the second. Okay, when I put it to 9y to the fourth, it was 17.260.
Okay, so this is the right answer. So I hope you get the point. I have given you this expression. The first derivative should be continuous. The first derivative should be continuous. If it is not continuous, there may be some issues. So what we have obtained, the first derivative was not defined at a point. It was tending towards infinity. So the length was, we cannot get the length from this expression. So we have changed the way of writing the curve. We are writing x equals gy. We are using the length of curve of arc length formula for y, and we have obtained the answer using the numerical approximation. Got it?
Yes.
Okay, now there is a similar question, not so similar, but yes, it should be something related to that. Again, the same statement, my derivative of y should have a continuous first order derivative. Look at the graph. There is a mode given to you. And mode, as you know, it is not defined at 0. Oh, sorry, it is defined at 0. It doesn't have a derivative at 0. Am I right?
Right.
So mod x doesn't have a derivative at 0. Just look at the graph there carefully. So everywhere it seems like to be a peaceful, but there is a sharp change at 0. Wherever you find a sharp change, the derivative does not exist. So how should I deal with it? Okay. So the only expression I told you that mod x have an issue somewhere. So let me use, it is going to be x whenever x positive and minus x whenever x negative. So using this, let me just rewrite this y. This is going to be x squared negative 4x minus x, which is equals to x squared negative 5x whenever x is positive, and x squared positive 4x. See, I have replaced mod x by minus x for the case x less than 0. Negative x was there. Let me tell you once more. I have changed this term. It was 4 mod x. I'm writing with a positive sign. Why? Because mod x is minus x whenever x is negative. When you simplify this expression, this is going to be x squared negative 3x. No doubts?
No.
So, and what are the range basically? I need to go from negative 4 to 4. But because there is an issue at 0, what should be my formula? My formula should be, I should start from negative 4, go up to 0, and then after from 0, I will go up to 4 there. This is what I can do. So for each sub cases, I need the derivative. It is 1 plus dy over dx for each case. Am I right?
Yes.
So I hope you get the point, because the function is not differentiable at 4, sorry, at 0. So I'm just changing the range from minus 4 to 0 and 0 to 4. Now please try to help me. This is going to be negative 4 to 0, square root of, what is the derivative when x square minus 3x? Am I right?
So
This is going to
right.
be 2x minus 3. Am I right?
Yes.
And dx is there. Similarly, you will be having 0 to 4. And then after square root of, what should I write?
1 plus parentheses
2x
2x
minus
minus
5.
5x.
Oh, I made a mistake. Should it be positive only? X square plus 4x minus x, it should be positive 3x. So that is a mistake from my side. You got it?
Okay.
This is a calculation error. So now you use your calculator to tell me what is the exact, or not exactly, approximated integration of first term, approximate integration of second term. Try to add them and tell me what should be the final answer using the
Okay.
calculator. Done.
Would it be 19.556?
Perfectly okay. It is 19.56 without any issue. Okay, so I hope you get the idea that whenever the derivative is not defined at a point, so we can bifurcate the interval for getting the arc length. Okay, we can convert like -4 to 0 and 0 to 4. Any doubt there?
No.
So based on that, we have a question. It is a quick just yes or no type of question for you. Some questions, some terms are given to you 6, 7, 8, 9, 10. These are the question name. Identify all values of x for which the function fails to differentiable. Tell me for question number 6, what are the points for which x is not differentiable?
It should be at x equals 4 and -4.
Only 4 there.
Oh,
So
okay.
always remember, whenever x minus a is there, the graph will be suppose this is a, this is the type of graph you will be having. So there is only point a is there at which the function is not differentiable. Do the same exercise for the second one. At what
It
point
should
the
be
function is not differentiable?
it should be differentiable on all from negative infinity to infinity.
No, just try to differentiate. So when you take the derivative, it is going to be 5 into 2 by 3 x power negative 1 by 3. Intentionally, I'm writing this expression as 1 over x power 1 by 3. No doubt? Do you have any issue?
No.
Now look at the expression on the right hand side. This term x is going, if it is 0 in the denominator, if it is 0, the derivative is not defined. So derivative does not exist at 0. 0 is the point where the function has an issue. Right?
Right.
Okay, just do the same calculation for the 8th question. Tell me the point at which this function is not defined. The derivative is not defined, sorry. Take the derivative, try to get the points.
Okay. -3.
Negative 3. Just a second. I think you're right. No issues are there. In the second and the next question, if you can notice, this is going to be x minus 2 whole square. Am I right? Square
I
root
think
of,
so.
and always remember one statement. The square root of x square is going to be mod of x. So I should be able to rewrite this expression as mod of x minus 2. And like I told you, whenever mod is there, a is the point where the derivative is not defined. Here, the value of a is going to be 2. Right?
Right.
In number 10, if you just look at the questions, there is something sin x exponent 1 by 3. So when you differentiate this term, you will be having 1 is 0. This is going to be cos over, I forget to write 1 by 3, sine power 2 by 3x, right?
Right.
So if the denominator is 0, we have an issue. Denominator is a term, in the denominator, there is a term trigonometric expression, sin x is there. When sin x is 0, sin x will be 0 whenever x is going to be integer multiple of pi. Integer multiple of pi. And this serves the purpose. These are the points where the function is not differentiable. Any doubt there?
No.
Perfectly okay. So now we have some set of questions from 1 to 10 exercise. These are simple tasks for you. You can use exact calculation if it is possible, or you can use what you say calculator to get the expression. If this gray portion is not there, that means you can calculate the length of the curve without any issue. Please try to help me. Question number
Okay.
1 to 3, they are going to be obvious question. In 3, the range of y is given to you. These are simple question. I'm not interested. Let me just talk about number 7 there. Okay, 5, 6, I'm not interested. 7 there. So in 7, you have y equals integration 0 to x tan t dt. And the range of x is given to me like 0 to pi by 6. This is a curve. I need to get the arc length. For getting arc length, I need the derivative. Am I right?
Right.
And you must have done fundamental theorem of calculus. Can you please apply that theorem? What should be the derivative of the above expression?
It should be secant squared x.
It should be 10x only. Remember, whenever you take the derivative of a term a to x ft dt, this is going to simply fx.
Oh, I thought we were just taking the derivative of what was inside the integral.
Sorry, yes,
I thought we were going to take the derivative of what was inside the integral.
no, we are going to take the derivative of the integral. Y is a term containing the integration, so you need to differentiate the whole term. Okay,
Okay.
so that is the only thing special here. Other than that, if you ask me what is going to be L, it is the same expression 0 to pi by 6. These are the limits. Square root of 1 plus 10x square. Okay, it is the square of the derivative, and then after it is dx 0 to pi by 6. Square root of 1 plus 10 square is going to be secant square x. Sorry, I forget. Because of the square root, this power 2 will not be there. Integration of secant x can be obtained in 10x. So if I remember correctly, it is ln secant x plus tangent x. Okay, and these expressions are going to be positive. If you do have issue, you can just put the mode there. 0 to pi by 6, you need to just plug the values, you will be able to get the answers. So is it possible for you to simplify expression like this?
Yes.
Okay, and these are the questions should be done without the calculator. And now I'm just listing some question for you should be done with the calculator. So if you can spare some time, these are the tasks for you to practice the arc length. Okay, there will be some more material. So whenever the teacher will give you some additional material, I can discuss that with you. So this is how you should be able to just try this question,
Wait, can you go back to the last slide?
please. Yes.
Okay.
These are the questions should be done with the help of the calculator. Normal analytical answers will not be available to you.
Okay. Thank you. Okay.
Thank you. Bye bye. Enjoy.
Thank you.